All right. Welcome, you guys. So I've broken 3-2 into two different sections because it's kind of a beefy section. And also, I don't want to skimp on the word problems and just do like one example of a word problem at the end. And so what I've done is I've taken the applications of quadratic equations and made a separate video where we're just working on word problems. And then a video here where we're working on solving the equations themselves. And it's still a really big section, this part one that we're about to do. So let's go ahead and dive right in. And in addition to this video, I'm going to put some more videos in the link below because I just don't feel like there's enough practice for some of the really important topics that we're going to learn today. Okay, so we're going to talk about quadratic equations and quadratic functions in this section. Now, a lot of students hear quadratic and they don't pay attention to the details and they think of the quadratic formula, okay? We're going to, end pretty much with us learning the quadratic formula. But right now, we're just talking about quadratic equations. So that's an equation where the highest exponent is 2. So it's a polynomial equation with the highest exponent 2 is what we call quadratic. If the highest exponent had been 1, it would be linear. And when we graph it, it would make a line. So that's why it's linear. But this would be a parabola. This would be a degree 2. So this is what we call our quadratics. Now, the only difference between these two is this one is set equal to 0. And this one is set equal to f of x. So that's why this one's a function. And this one's going to be our equation. Okay. Now, it doesn't have to be in this order. We might get some of these quadratic equations that are out of order. But if it is written in ax squared plus bx plus c equals 0, then we say that that's standard form. Okay. All right. So you'll hear me say get it in standard form. So that just makes sure that you put it from highest exponent to lowest exponent. Okay. Now, you'll see the language change on some of the directions. And I just want to make sure it doesn't throw you off. All of these words mean the same thing. If they're asking for the zeros of a quadratic function, those can also be called the solutions, the roots, or the x-intercepts. Okay, so that's 4 names for the same exact thing. A zero, a solution, a root, or an x-intercept. Okay. Now, to find these roots, to find these solutions, we can use the first few examples that we're going to do are going to use these properties or these principles here, okay? So the first one is called the principle of zero products, at least in this textbook. In my old one, it was called the zero product property. But yeah, so the principle of zero products. So they're just kind of stating something that I think's, once it's pointed out to you is pretty obvious. If you have two things that are multiplying, aka if you have a product, and the answer is 0, then that must mean that either this A has to be 0 or B equals 0. If you think about it, right? 0 times 0 could be 0. So maybe they're both 0. Or 0 times 7 is 0. 0 times 8 is 0, right? So in order for us to get an answer of 0, either one of these has to be 0 or possibly both. Okay. And then the other principle that we'll be using is the principle of square roots. So, for example, if you have something like x squared equals, let's say 9, right? Well, we're going to square root to undo the squaring. Those are inverses of each other. Now, the main mistake I get is I get this on the next line. I get 3. And that's technically wrong, okay? Yes, 3 times 3 is 9, right? 3 times 3 is 9. But we're missing a solution. -3 times -3 is also 9. So anytime you square root both sides of the equation, you've got to remember to put a plus or minus in front of it. And that's what they're saying here. It's either going to be root k or negative root k. You've got to remember the positive version and the negative version. Okay. So these are going to be what we're going to use to solve many of these quadratic equations. So let's go ahead and start off with some where we use the principle of zero products. Okay, now on this first example, there are so many different ways to factor a polynomial. And so I'm going to make a separate video and know that there are just so many ways out there. Some teachers use the X, which is what I'm going to use simply because I've seen that used the most. And I'm trying to have it make sense to the most amount of people. I've seen some teachers using a box like this to try to get the factors. I read in a magazine once how to turn like any polynomial with a leading coefficient, which this one will become this, by the way. Okay. How to make it so it doesn't have a leading coefficient by writing it like this. Anyhow, I'm making some sort of substitution. So everything becomes a leading coefficient of 1. I mean, so many different ways, you guys. So I'm just going to show you a way that it helps you later on, because you are going to do factor by grouping in trig in this class, as you move along in all the other classes. So that's why I've kind of chosen to use the AC method. If you are interested in maybe seeing some of the other methods, because this one's just not sitting right with you, feel free to shoot me an email, and I can go ahead and show you some of those other methods, or maybe you're just interested. All right, so here we go. I'm going to go ahead and start. And know that there will be a video link for this example 1A, some more like it. So factoring with the AC method. All right, here we go. So the very first thing we're going to do, you probably already knew, is we're going to distribute that x in. So that's going to get us 2x squared plus x equals 15. Now, anytime that you have both an x squared and an x, you need to get all the terms on one side. I'm just going to write this down over and over, okay? Since there's an x squared and an x, since there's, sorry, an x squared and an x, get all terms on one side. Okay. All right, so we're going to have to move everything to one side, and the easiest way to get that done in this case is to move the 15 over. We won't always move things to the left. Sometimes we'll move things to the right if it's going to keep our leading term positive. That's the key. You always want to keep the squared term positive. Okay, so now this is where the AC method comes into play. You use the AC method when the leading coefficient is not, we can use it when the leading coefficient is 1, but specifically when the leading coefficient is not 1. And we'll consult that video if you need some more practice on this, okay? Use the AC method since the leading coefficient is not 1. Okay, so it's called the AC method because when you're, later on when we use the quadratic formula, you'll see that we label this A, we label the number in front of X, which is 1, the B, and we label this C. We just go alphabetically, A, B, C. Okay, so we call this AC method because of that. Now, what you're going to do is you're going to multiply A times C. So I'm going to do this in red so it pops a little bit. So we're going to take A and multiply it by C. So 2 times negative 15 is going to give us negative 30. Okay, so we're going to put that into the little X. And that's what we want. We want to multiply to make negative 30, but we want to add up to the middle number of positive 1. So I'm going to put an A for add here and an M for multiply. Okay. All right, so we have to find factors of negative 30. Well, the only things that I can think of that make 30 would be like a 3 and a 10, a 5 and a 6, a 2 and a 15. I'm going to write way more down than we need just so that you guys understand and get this practice. And of course, the trivial of 30 times 1, right? Okay, so you're looking for 2 things that multiply to make negative 30, but that add to make 1. So as far as all the things that I see here, these are going to add up to 1. Negative 5 plus 6 equals positive 1, right? So those are our winners. So those are what we're going to write in the box, okay? This is honestly the hardest part to factoring. And those of you that have factored before know, yeah, sometimes you can't find the numbers, right? It just takes a while, okay? All right, so negative 5 times positive 6 is what's going to do it. Now, how we use those 2 numbers that we got, at least in the AC method, is you are going to, order doesn't matter, you could put the 5 or the 6, okay? So let's say we put the 5 here, and we put the 6 here, and then we keep everything else the same. Now what's happened here? Let's see. These match up. This matches up. This matches up. So the only thing that we've done is we've re-expressed this positive 1x that's in the middle by using two terms to make it. Negative 5x plus 6x adds up to 1x. So this is equivalent to the equation on the line above it, if you were to combine the two middle terms, okay? Nothing else has changed. Okay, so we're going to use factoring by grouping now. Factoring by grouping is used when you see four terms like we have. One term, two terms, three terms, four terms, okay? And that's going to be throughout the class. It's going to get used a lot, you guys. So we're basically thinking about splitting this equation down the middle and only looking here for right now. And we're going to say, okay, well, what's the greatest common factor? What's the GCF? What can we take out? Well, the only thing that we can take out is an x. So that'll leave us with 2x minus 5. Now, whatever sign is here, you have to take it out. I'm going to take out a plus because it's already plus. And then let's see, 3 goes into both 6 and 15. So we're going to be taking out a positive 3. So 6 divided by 3 is 2. 15 divided by 3, so it's 5. Now, if it factors or if you've done it right, sometimes we mess up. These should match. That's a good sign that we've done it right. Now, those are going to be, that's going to be one of our parentheses. And then the leftovers are going to be the other parentheses, this x plus 3. Okay, so you've basically taken the 2x minus 5 and you've kind of like factored it out of both terms. That's why it only shows up one time right here. Okay, because you factored it out. You want to think, okay, well, if I multiplied it times the x, that'd get me this. And if I multiplied it by the 3, that would get me this. Okay, so you took it and you factored it out of both terms. Okay, now we're at the point where we can use the principle of zero products, right? Just make sure that the principle of zero products. All right, so what I'm gonna type that in here so you understand how this relates to that very first slide. Okay. So remember that principle says if A times B equals 0, then A equals 0 or B equals 0. Okay. So we have that. If you look over here, we have something times something and it equals 0. So then either this first thing, 2x minus 5 equals 0, or this second one, x plus 3 equals 0. And then you're just going to solve those. You're going to add the 5 over, divide by 2, x equals 5 halves. And we'll move the 3 over, changing its sign. X equals negative 3. Now, something to note, the number of answers that you get should match the highest exponent. I'm going to write that here if you include multiplicity, okay? So the number of solutions, including multiplicity, we'll talk about that later, multiplicity, should match the highest exponent. So this is going to help you catch yourself if you've made some errors. You're going to go ahead and you're going to say, okay, well, I got 2 answers. And you'll go up here and you'll say, okay, well, how many answers am I supposed to get? Well, the highest exponent is 2, and we got 1, 2. Okay, I got them all. I'm not missing one. Usually it's the case that people are missing one. Okay. All right. So there's our zero product property in action. If you ever see something times something equals 0, then set each piece equal to 0. So let's try another one. Again, we have an x squared and an x. We said any time that you have both an x squared and an x, get all terms on one side. Now get it on the side that's going to keep the squared term positive. So in this case, we will move the 8x over. That way we can keep the squared term positive. So we subtracted it over to the other side. That's why the sign changed on it. All right, now we're going to go ahead and factor out. Now this is not an AC problem since there's not 3 terms, okay? You're only going to use that factoring with the AC if there's 3 terms, okay? Don't use the AC method since there aren't 3 terms. Sorry guys, terrible typer. We're just going to factor out the GCF, the greatest common factor. All right, so looks like 8 goes into both, 8x, right? So we're going to take out an 8x. And now we're ready to use the zero product property, right? We have something times something equals 0. So we're going to use the principle of zero products, right? So we're going to set each piece equal to 0. In other words, we're going to set the 8x equal to 0. And we're going to set the 3x minus 1 equal to 0. Oops. So we get 0 for this one. We're going to move the 1 over. So it should be positive since we added it over. Okay, we're going to do an exponent check. The highest exponent in our problem was 2. So there should be 2 solutions, which we got. So we're looking good there. Okay. All right. So we're looking pretty darn good. All right, now sample 2. This is going to use that second principle, the principle of square roots, okay? Now you can tell that these are different than the last 2 because they don't have both an x squared and an x, okay? It only has an x squared, okay? So since there's only an x squared, only an x squared, okay? We're going to isolate whatever is being squared. Isolate what's being squared. Okay. So in this case, what's being squared is x. So we're going to isolate the x squared in this case. So we got to get rid of that 3 first. I have some students who square root right away and they end up missing it. Make sure you isolate whatever's being squared first. The 3 is not being squared, only the x is. Now we can do the square roots. Now the reason why we do square roots is because we're always doing opposites, right? If it's multiplying, we divide. If it's adding, we subtract. If it's squaring, we square root. Now remember we said, don't forget plus or minus before you square root. Remember, 2 times 2 is 4. But so is -2 times -2, because a negative times a negative equals a positive. And if you do that check that I told you to do, then you won't mess this up, okay? So we would have said, okay, let me make sure that I have 2 solutions since the highest exponent is 2, right? Since the highest exponent is 2, there should be 2 solutions. If you don't have your plus or minus, then you only have 1 solution, and then you would find out, oh yeah, I forgot to put my plus or minus on this. Okay. All right. Solve using square roots. All right, so we have to isolate the whatever's being squared, right? So we have to move the 25 over to the other side by subtracting it over. So it'll be a -25. Then square root to get rid of the squared. And so we get x equals plus or minus. I'm going to put them in there already before I break the root down so that I remember that it has to be there. Okay. All right. So good thing we just did a whole section, right, on complex numbers and I and stuff. We know, oops. Sorry, you guys. There we go. We know that if there's a negative under the radical, that we have to pull the negative out. So we're going to pull the negative out and make it an I. So we have plus or minus I root 25. All right, well, the square root of 25 is 5. So this is going to be 5 plus or minus 5i. Again, you're going to check and see, are there two solutions? There should be, since the highest exponent is 2, right? Okay. So since the highest exponent is 2, we need 2 solutions. Sorry, you guys. Okay. All right, 1, 2. Positive 5i, negative 5i. Telling you this exponent check is going to catch you if you forget your plus or minus. All right, now, whenever I have students solve this, they don't read the directions, which I don't blame them. I did a lot too. When I was doing my math, I just like dive right in. And so they FOIL this out and like take a really long way to get there. Now you could get the answer if you do x plus 7 times x plus 7, okay? But I'm not going to do that because I'm looking at the directions, and the directions say solve by using square roots. And that's going to be the quicker way anyways. Plus, I'm trying to prep you guys for completing the square. So we really do want to do this way. All right, so to get rid of a squared, the quickest way would just be to square root both sides. Just don't forget your plus or minus, right? Okay, now we're going to break down the 8. So remember, you can break down the 8 by prime factorization. Doubles go on the outside. Singles go on the inside. Or you could break down the 8 by saying, okay, the square root of 8 is the square root of 4 times the square root of 2. So it must be 2 root 2. All right, or if your teacher lets you, just use your calculator to get it done. Okay. All right. So it'll be a negative 7, right? And it'll be 2 root 2 for the 8 part. Now the question is this really 2 solutions? Yes, right? Negative 7 plus 2 root 2, negative 7 minus 2 root 2. So we really do have 2 solutions here. Look how quick that was. Could you imagine if you were foiling and trying to like factor, or actually you'd have to use the quadratic formula on this one, you would still be like not even halfway done with the problem. So this was super quick. Okay. So that is using square roots. All right, so let's talk about completing the square. Now, the purpose of us doing completing the square for solving is honestly just so we can work our way up to the quadratic formula. We'll probably never use completing the square to solve again once we know the quadratic formula. But we are going to complete the square, not to solve, but to have a perfect square many times in this class. When we get something into vertex form for a parabola, when we do conics later on, like ellipses and hyperbolas and circles and stuff, we're going to need to know how to do it. So it's not like this, we're just doing this to get to the quadratic formula. We're going to use completing the square a lot, just not for solving, okay? All right, so I'm going to write down, what the text has, and then I'm also going to write it in like my own words that are a little shorter, just because like my brain's full. I got to keep things compact. Okay, so if you're given a quadratic equation in standard form, right? Here's your 4 steps for getting it done. So the very first thing you're going to do is divide both sides by a to make the leading coefficient 1. In my mind, shorthand, you'll hear me say get rid of a. Then it says isolate the variable terms on one side of the equation. My shorthand for that is get rid of c. Okay. And that's, see how these are variable terms? This one doesn't have the variable x. That's what we mean by get rid of c and move it over to the other side. All right, and then complete the square. Add the square of 1/2 the linear term coefficient to both sides, then factor. So I'm just going to put add 1/2 of b squared to both sides. This one's not that much shorter. And factor. Okay. And then finally, I just put solve by square roots, right? So solve by square roots. Solve using square roots. Okay, so those are going to be our 4 steps. Get rid of a, get rid of c, add 1/2 of b squared to both sides and factor, and then solve using square roots. So let's go through. The first couple times I'm going to write out all the steps till we get used to it, and then I won't write the steps out anymore. Okay. All right, so step 1 is to get rid of a, right? Oops, not step 1. Step 1, get rid of a. Okay, so in this case, there is no a, right? Like it's already a 1, okay? So I'm going to write that down. Since a is already 1, we are done. There's nothing in front of the x squared term, so we're done with step 1. All right, oops, step 2. Typo. Rid of c. Okay, so we have this equation, x squared minus 18x plus 5. We got a, b, and c. We're going to get rid of c, so we're going to move that 5 over to the other side, making it -5. And in the future, I'll leave a space and stuff, but we'll work our way up to that. All right, step 3. This is when we add 1/2 of b squared, right? Add 1/2 of b squared. I don't, this doesn't have a math to both sides. You know what? I'm just going to leave a space. Add blah, blah, blah to both sides and factor. Yeah, and I'll type in or write in 1/2 b squared. All right. Oh, I didn't put step 3. Oh no. Okay, I'll just rewrite it. Okay. All right, so basically, let me just do this first. Do a different color. We're going to be taking 1/2 of b and squaring it. Well, a is 1 and b is -18, right? So we're going to take 1/2 of -18. Well, 1/2 of -18 is -9. So that means we're going to be adding 81 to both sides. So here we go. We got our x squared minus 18x equals -5. But we just found out that we're going to be adding 81 to both sides. Now, we're going to factor. In the future, we're going to skip this step because there's kind of a shortcut for it. But we're looking for things that multiply to make 81, multiply, and that add to make -18. Yeah. Well, let's see. -9 times -9 is +81. And -9 plus -9 is -18. So that is going to be what we use. Now, I want you to notice, so this would be x minus 9 times x minus 9, right? And then -5 plus 81 would be 76, okay? Now, it's called completing the square because this number you added will always make it factor like x, like same number times same number, x minus 9 times x minus 9. So you can write it as a square. So it won't be two different numbers, you guys. It won't be like, well, this time 2 times 18 worked. It'll have to be 18 and 18, right? Or 2 and 2. All right, now, this is not a coincidence that this number and this number match. They will always match, you guys. So that's our shortcut when things start getting hard. If you can't find the numbers, these will always match. Okay. All right, so now to get rid of the squared, we're going to square root. And this is just like that last example we did, right? So we're just kind of prepping ourselves for this. Don't forget your plus or minus, right? Okay, and then we're just going to move this up here into the corner. Save space. All right, I got to check and see if 76 breaks down. 76 is 2 times 38, which is 2 times 19. It looks like it does break down to 2 square root of 19. Let me double check myself. Square root of 76 equals, yeah. Okay, so 2 root 19. All right, so then this is going to become x minus 9 equals plus or minus 2 root 19. And we're just going to move that 9 over. And we have our 2 solutions, right? 9 plus 2 root 19 and 9 minus 2 root 19. Okay, so this should be like really tough. I mean, this is a lot of steps. I didn't even put step 4 down, huh? Which is just solve. Once you get it down to this spot, step 4 is to just solve, right? All right, let's try it again and again and again until we get good at it. All right. Step 1, right, is to get rid of a. Now this time we really do have an a, right? So let's see here. So if we get rid of a, we're going to be dividing by 2 to everybody. And that's what's going to, I usually get rid of a, but really it's going to turn a into 1. All right, now step 2. Step 2 was to get rid of c, right? All right, so to get rid of the c is the -3/2, right? So we're just going to move the -3/2 over to the other side, making it +3/2. Step 3 is use the add 1/2 b squared, right, to both sides and factor. Now, remember the factoring is going to be a lot easier now that we know that shortcut. All right, so the b in this case is -2. So half of -2 is -1. And -1 times -1 is 1. So that's what we're going to be adding to both sides. So we have our x squared minus 2x equals 3/2. Well, we're going to add 1 to both sides. Okay. Now, look how much easier this is going to be, right? Now that we know the trick. Since there's a -1 in the parentheses before the squaring, that means it's going to be -1 here. Let's just double check them because it's still new and make sure that you guys see that, okay? We would be looking for factors of the last number, which is +1. And then we need those, oops, sorry. All right. And they have to add up to the middle number of -2, right? So we said it's -1. Let's check. -1 times -1 is +1. -1 plus -1 is -2. So it worked. So this trick of that these have to match this And this guy right here works every time, you guys. It's going to be really great on the next example where we have fractions. All right, so to do the 3/2 plus 1, let's just quickly do that off to the side, or you can use your calculator, right? 3/2 plus 1/1. I need to multiply by 2's. So it'll become 3/2 plus 2/2. So it's going to become 5/2. You just use the calculator in my class, right? So you'd say, oh, sorry, let me clear this out. 3 divided by 2 plus 1. Or if you like to use this button, 3 down arrow, 2 right arrow plus 1. There's your 5/2. Okay. All right. Now we're at the solve by taking square roots. Sorry, I didn't type it out last time. But that's what step 4 is, right? Step 4, solve by square roots, I'll just say. Okay. All right, so what that means is, move it up a tiny bit so I can fit in line in at least. That means that we're going to take the square root of both sides. And nobody's going to forget their plus or minus, right? I never did. Lies. Okay. All right. Anything you could forget, I'm telling you I did. Okay. All right. So where'd my arrow go? There it is. It's back. Okay. So then that's going to leave us with x minus 1 equals plus or minus 5/2. All right. So now we just need to move the 1 over, right? Oops, I forgot the square root over this guy, right? You know what? I almost feel like I should rewrite that because it's so messy. Sorry, you guys. There we go. Okay. So then we'll move the 1 over to the other side, making it positive 1. And I'm going to go ahead and take the big, you know what? Let me just leave it for now. All right, so okay, so off to the side, let's just kind of take a look at breaking down this root. So the problem with this, the square root of 5/2, is they're both being square rooted, which means we have a root in the denominator. That is not allowed. So what we're going to do is we are going to do a process called rationalizing the denominator. It basically just means getting the radical out of the denominator. Okay. All right, so no radicals are allowed in the denominator. So we will rationalize the denominator. All right. So let's go through that process. We kind of talked about it in the last section. So basically, you're going to multiply by the denominator, root 2/2, over root 2/2. Because this is really just you multiplying by 1, which we said earlier. You can multiply by 1 and it's not going to change the value. So that's why that's legal. So if we multiply by 1, it's going to become the square root of 10 over the square root of 4, which just leaves it as the square root of 10/2. So see how that worked? It made this a perfect square, which means we can square root it. So the denominator no longer has a radical. That is the process of rationalizing the denominator. We took it from an irrational and made it a rational number. There is our answer. Okay, so this one had an A. So we had to divide through by 2 to everybody. After you get rid of A, get rid of C. So we moved the 3/2 over, changed its sign. We did the whole half of B squared thing. We added it to both sides. And we said, don't think too hard about how this factors. It's always going to be the number before you square. So x minus 1 squared. To get rid of a squared, you just square root both sides. Don't forget your plus or minus. Okay. Move that 1 over to the other side. and then rationalize the denominator. Okay, that was a tough one. Each one gets progressively tougher. So I'm not going to write out the steps, we'll just verbally say them. Okay, now we do need to get everybody on one side first before we start. This one's kind of out of order and stuff. So let's get them into the proper order before we even start the steps, right? Okay, so we're going to get rid of A. That means, hopefully you said, divide by 3. Thought it. Next step, get rid of C. And I'm going to leave a little space where the 4/3 was, because we know that we're going to be doing half of B squared, right? So we're going to be taking half of negative 2/3. So that means that these 2's can cancel, leaving us negative 1/3. And negative 1/3 times negative 1/3. Well, that's going to get you 1/9. So we're going to add 1/9. You know what? Let me do this in a different color so it pops a little more. Okay. All right. So this is where that trick comes in handy. I mean, nobody wants to be looking for factors of 1/9 that add up to negative 2/3. You just don't. But we already know it's going to be the number right before you square. So it's going to be negative 1/3, right? All right, so those match. And then it's going to be, we're going to have to do 4/3 plus 1/9. Let's do it in green. So we would have to multiply by 3 this time to get a common denominator. So that's going to be 12/9 plus 1/9, 13/9 it is. Okay. All right. So then let's see here, square root. We're on step 4 now. Square root both sides to get rid of the squared. Now this one's a little different than the last one. We can, when we break the square root up from one big root to 2 little roots, this actually square roots. So I don't need to rationalize the denominator in the way that we just did. It'll automatically become a rational number because the square root of 9 is 3. Boom, done. I don't have to do all that work I just did. Thank goodness. Okay. So we had a positive 1/3. There we go. There's our 2 answers. Okay, so this is going to get us ready for the quadratic formula. We are actually going to derive it. Now, if you're like not interested, you know, I think this is cool, really, really cool. And for people who are like really into math, they want to be math majors, or they just like these types of things, you know, proceed to watch. I'm not going to test you on this or anything. This is just for the heck of it. So go ahead and watch it. You know, if you're like know you're majoring in math and want to teach someday, or just really like math a lot. Otherwise, you can skip on to the next section, you guys, to the next problem. Not the next section, the next example. All right, so we're going to prove the quadratic formula. So somebody got sick of completing the square, and you can see why. It's a very long process, okay? And they said, you know what? I'm just going to write down a generic quadratic. I'm going to leave variables where the coefficients would be. So I'm going to leave A, B, and C in it. And then I can put in whatever A, B, and C I feel like, you know, like for the last example, right? 3 would be the A, -2 would be the B, and -4 would be the C, okay? We're just going to leave them abstract like this and do all the math here. So let's go through the process that we've been going through, right? So step 1 is to get rid of A. 0 divided by anything is 0. Step 2 is to get rid of C. So we're going to move C over A to the other side because that's what's acting as like our C. So it'll be negative when we move it over to the other side. Step 3 is to use the formula where we take half of B and square it. So B in our case is going to be B over A. That's our B. Kind of feels weird to say that, but hopefully you guys get it. All right, 1 times B is B, 2 times A is 2A. And we still have to square it. So B times B is B squared. 2 times 2 is 4. A times A is A squared. So we've got that we're going to be adding to both sides of the equation. Whatever you do to one side of the equation, you have to do it to the other. Now remember, don't think too hard. The factorization for this polynomial, where you know it's going to be x, will be whatever's inside right before you square, right? I'm going to change this to remind you. This is a positive, so it's going to be plus E over 2A. And I'll highlight this guy in orange so we understand that those always match each other. Meanwhile, over here on the right-hand side, in order to make the denominators match, I have to figure out what I would need to multiply by, right? Well, it looks like I would need 4 and another A to get the A squared. So whatever you do to the bottom, you got to do it to the top. So this gives us, if we multiply right here, we're going to have negative 4AC over 4A squared plus B squared over 4A squared. Okay, so I'm going to rearrange the order. I mean, we know in the quadratic formula, if you look up, that it's B squared minus 4AC, right? So I want the B squared part to be first. And then the minus 4AC part to be last. I always do this like when I'm doing a proof, kind of like look up and go, okay, well, what do I want in the end? And that helps me figure out what I need to do. All right, now because these have the same denominator, we are allowed to just write them as 1, right? We can say, all right, B squared minus 4AC and put it all over 4A squared instead of individually. That's kind of like if I said to you, hey, can I write 4/5 minus 1/5? Can I write that as 4 minus 1 all over 5? Yeah, either way, the answer is going to be 3/5, right? So you can combine them into 1 if you want. And that's what we've done here is we've just combined them into 1. All right, so we got this. I think you guys know the next step. We got to get rid of that squared. So you get rid of the squared by square rooting. Just don't forget your plus or minus, right? All right. Now it's one big root, but it really goes over both terms, or both the numerator and the denominator. But I'm going to split it up into 2 little roots because one of them will be square rootable. One of them is a perfect square. If you look, the top will not square root, but the bottom will. Square root of 4 is 2, and the square root of A squared is A. So this is going to be 2A. Right, I'm going to kind of move up over here now so I'm not going too far down. Okay, so the next step is going to be me moving this over to the other side. Boy, it's slowly starting to look like the quadratic formula. Oh my goodness. I already see a lot of the quadratic formula in this. Okay, so. Sorry. There we go. Now I can see the quadratic formula on the screen. Okay, so we're almost there, you guys. I mean, look, we got the negative B plus or minus. We have all that. The only thing is we have two separate fractions. Well, we really want to put it all over 2a and make it one fraction, right? Now we have the quadratic formula. So we can use this instead to solve for us, instead of using that completing the square process, which was kind of long. So let's go ahead and actually use it. Super cool, right? It's like, I remember the first time I saw this, I had already used the quadratic formula for years, and I was like, oh my gosh, that's where it comes from. Some of you might not totally understand this right now. I had a lot of students who did the proof for extra credit at the end of the semester because they were like, oh, when you first did it, I thought like you were making junk up, is what they said. And they're like, now I get it. And they were able to prove it really easily at the end of the semester. But when I did it, right now towards the beginning, it kind of flew over their heads a little bit, which is perfectly fine. All right. Okay, so now we're going to use it. So when it says solve, I don't really want to do completing the square. Completing the square, it's actually kind of long. Let's use this quadratic formula. Okay, so I've distributed. We got to get it into standard form. So I'm going to move all terms onto one side. And we want to keep the squared term positive. So we're going to move the 7 over instead of moving the squared term over. All right, now it is in standard form, ax squared plus bx plus c equals 0. Now I'm able to answer the questions, what's my a, what's my b, and what's my c? So a is going to be the number in front of x squared, never a letter, well, in this case, right, don't include the x's, it's just the numbers, you guys. The b is going to be the -6, and yes, you have to include the sign with it, and the c is going to be a +7. Now, I always write out the quadratic formula to ground myself and to help me memorize it. I had some teachers along the way that made me write it out, and I still to this day, do. And I'm grateful that they did. All right, negative b, but b is -6. So it's going to be negative, right? B squared minus 4 times a, which is 2, times c, which is 7, all over 2 times a. All right, so the minus that you see, right? Negative, that's going to make it a +6. And then inside the root, -6 times -6 is 36. And we have a minus sign, and we're just going to multiply all 3 of these numbers. So 4 times 2 is 8. 8 times 7 is 56. All right, 36 minus 56 is going to be -20. All right, so let's break down the -20. We know that you can't have a negative under the radical. You've got to make it an I and turn it into a positive. Then 20 breaks down, right? You can break down 20 by saying it's 2 times 10. It's 2 times 5. So it's 2 root 5. 2i root 5. Okay. So that's what's going to go right here is 2i root 5. And then it's all over 4, right? Okay. All right. Another way that we said that we could break down the 20 is just thinking of it as 4 times 5. And that's how you're going to get 2 root 5. Okay, so now we're going to split up the fraction just like we practiced in 3-1 with I. The 6 is over the 4. And the 2i root 5 is also over the 4, right? I don't like that 5. Let me make that a little bit better. All right. So it looks like we can divide by 2's. For almost everybody, huh? Okay, so if we do that, 6 divided by 2 is 3. 4 divided by 2 is 2. 2 divided by 2 is 1i. 4 divided by 2 is 2. Now there's lots of ways to clean it up from here. I'm just going off what I know, like if I give a multiple choice test, they split it up like this usually. They don't leave it combined as one fraction. But whatever your teacher in your class is saying to do that. A lot of times in the past, I would just have them reduce all of these by 2's right here. But just because I noticed how the test generator generates multiple choice answers, I just wanted to get you guys ready for that. All right, so our first time using the quadratic formula, we're going to use it so much in this class, okay? I'll probably include some more examples on that too, just so that you get that practice. We're doing so many essential skills in this section that are just really important. All right, so we're going to go ahead and take things that actually aren't quadratics, but rewrite them in terms of quadratics. So you can see here, this is not a degree 2 equation. This is degree 4. This is quartic, but we're going to reduce it down to a quadratic. And this one has rational exponents, right? It's got a fraction in its exponents, and we're going to reduce it down to a quadratic. Okay, so let's start off because we're going to compare them all to this quadratic right here. So let's make sure we know how to solve this. So I'm going to solve this one by factoring. This isn't really the AC method. When the front number is a 1, you could use the AC, but it'd be simpler to just go right to the factors. So we're looking for factors of the last number, -4, that add up to the middle number of -3. So -4 times 1 would get you -4, but -4 plus 1 would be -3. So we're going to go ahead and go right to putting those into the parentheses, the -4 and the +1. Okay. If you were to FOIL this out, if you were to distribute, you're going to get your x squared at the front. You're going to get a 1x, and you're going to get a -4x. So that makes -3x. And then you're going to get a -4 when you multiply the last. So this is equivalent to the equation above it. Okay. All right, now we're using the principle of zero products, which says if A times B equals 0, then either A equals 0 or B equals 0, right? So we're going to set this piece equal to 0. And we're going to set this piece equal to 0. So if we move the 4 over or add it over, we'd get +4. And if we move the 1 over or subtract it over, we get -1. Now, that solving is going to happen on both of the next two because they will reduce to this exact quadratic. So the way that we take something like this and reduce it down to a quadratic is we start off by writing it as x squared squared. That's still going to be x to the 4th. But what it does is it allows us to make a u substitution on it. Okay, you can see that we have x squared twice in the problem. So we're going to let u, we're going to let u be x squared. So in other words, everywhere where we see an x squared, we're going to write a u. So this will become u squared, and this will become -3u. So now we've taken a quartic and reduced it down to a quadratic. It started off degree 4, but now we're looking at something that's degree 2. And this is actually the same exact polynomial on the slide before, right? Just instead of x's, we've got u's, but it's the same polynomial. So it would factor in the same way as the last one factored. And remember from here, we set each piece equal to 0. And we got 4. And then we set u plus 1 equal to 0. We got -1. Now, the only difference is we're not done here. If the equation starts in x's, it needs to end in x's. Okay, so you need to put your x's back. Okay, so at this point, we need to remember that u is really x squared, right? So that means that we're going to write this as x squared equals 4. And x squared equals -1. And we'll solve both these equations. Now, if you're doing the exponent check, you know you're wrong. So you only have 2 answers. but this is degree 4, we should have 4 answers. So when we go in to solve these equations that we just wrote, so we'll square root. Don't forget your plus or minus, right? -2 times -2 is 4. +2 times +2 is 4. And don't forget your plus or minus. Now that is the definition of I. I is the square root of -1. But if you forgot, you can still pull out the I. And the square root of 1 is 1. So that's how you'll get your plus or minus I, just in case you forgot. So there's 4 answers, which makes sense because it is a degree 4 polynomial. Okay, we're going to use that same idea of a U substitution in this next one. So we want to write this as x to the 1/3 squared. And now don't think too hard about how to write it. It always has to match the middle term. Notice this is an x to the 1/2, and I'm sorry, I wrote that down wrong. Should be 1/3, you guys. There we go. All right, so this middle one's an x to the 1/3, and what's inside the parentheses is x to the 1/3. They have to match, just like on our last one. The middle one was an x squared, so this one has to be an x squared. That's what's going to enable us to make the substitution, right? So we're going to let u equal x to the 1/3 this time, okay? So this will become u squared minus 3u minus 4 equals 0. So we reduced it down to that same polynomial, right? And I'm not going to do all the math again a third time, you guys. Oh my gosh, I can't write U's. I did fail penmanship like all the time when I was in elementary school. All right, so then if we set each piece equal to 0, we get u equals 4. And u equals -1. But remember, u is really x to the 1/3, right? So we're going to put that back at this stage of the game. So it's going to be x to the 1/3 equals 4. And it's going to be x to the 1/3 equals -1. And then we're just going to multiply by the raise both sides to the reciprocal power. If it's 1/3, then we're going to raise it to the 3/1. It's 1/3, then we're going to raise it to the 3/1. And the reason why we're going to do that is because now these can cancel out, right? We can say, well, let's cross cancel those 3's out. And it's just going to be x to the 1st, aka x. 4 times 4 times 4 is going to get you 64. Same thing here. We're going to cancel out those 3's. That's why we raise it to the reciprocal power. So x to the 1st equals -1 times -1 times -1, which will get you -1. Okay. All right. So we have these equations that didn't seem like they were, quadratic, like we were able to like factor and stuff on it, but we reduced them to quadratics and it helped lead us to the solutions. Okay, guys, so just a couple of comments. I'm going to include a couple of links to videos where we practice factoring with a leading coefficient, factoring without a leading coefficient. Let me see if there's anything else that I feel like more practice would be needed. Maybe possibly some more quadratic formula questions. We'll have to see what I have time to make. But I really think that practicing the factoring is just going to be key here because that's not going anywhere, you guys. In fact, you'll factor on things that have sine, cosine in it when you get into trig instead of just x's. So that's going to be a big, big deal. All right, you guys. Well, thank you for joining me. And remember that part 2 of this will just be all applications. So word problems involving quadratics. All right, take care.